To construct a confidence interval for estimating a population proportion, you use a single sample z interval. For the state portion, say that you want to estimate p, which should be the proportion defined in context at a certain confidence level. Under plan, say that we should conduct a one sample z interval for p if the conditions are met. The random condition simply asks for a random sample or a random assignment. The 10% condition requires that the sample size is no more than 1/10 of the population size. And the large counts condition requires that there are at least 10 successes and 10 failures, which occurs when n times p hat and n times 1 minus p hat are all at least 10. To do this problem, plug in all the values into the equation for the confidence interval, which is given here. And then in conclusion, you want to state that you are whatever percent confident that the interval from your two values found captures the true proportion in context. A common mistake might be getting a z value confused with a t value, even though those are used for two different tests that you don't want to confuse. To find a z interval using a graphing calculator like a CI-84, first go to Stat, and then go over to Tests, and then scroll down to one prop z interval, and then you can enter your data and the confidence level that you want to use, and then it will give you your complete z interval.
Alright, here's the outline for a single sample t interval. For the state, we want to say we want to construct a blank percent confidence interval for the true mean value of the parameter in context. Plan, we should use a one sample t interval for mu if conditions are met, which is random. Make sure you state out the full sentence and not just random check. Normal large sample and 10% condition. For the do, we use this equation. Make sure you show your degrees of freedom, the equation with all the values plugged in, and also the interval. And conclude, we are blank percent confident that the interval blank captures the true mean value of the parameter in context. Make sure you list your DF, which is n minus 1, and check 10% for samples without replacement. D4 plus, you're going to go to stats, then you're going to go to tests. You're going to go down to number A, which is your t interval. Now you can either type in the data given on the list, or you go to your stats. You plug everything in given to you from the problem, and then it gives you your interval.
Now we'll be going over how to construct a two-sample z interval for difference between two proportions. As usual, we'll be following the four-step process. First, state parameters that you want to estimate and at what confidence level. For the plan part, identify the appropriate inference method and check that the conditions listed here are met. Once you've checked the conditions are met, perform calculations using this formula here, with c star equal to the critical value for the standard normal curve with c% of its area between negative z star and z star. As a reminder, this part of the formula is just a standard error. Finally, to conclude, you can use this sentence frame here. Be sure to mention the context of the question. Using a calculator, on the TI Nspire, we go to Menu and down to Statistics and Confidence Intervals, and then choose True Proportion Z Interval, and enter in all your values, and then the calculator will calculate the interval for you. But when using a calculator, make sure that you write down all the necessary variables that you entered and show sufficient work in order to gain full credit.
The four-step procedure for a two-sample t interval varies a bit from a two-sample z interval. In the state section, you want to write out the parameters of interest and the difference you want to estimate at what confidence level. For plan, you should list the appropriate test and check if the conditions are met. When checking the normal or large sample condition, you need to make sure that sample size n1 from population 1 and sample size n2 from population 2 are both greater than or equal to 30. And you want to remember to list the degrees of freedom in at least one of the four steps mentioned above. Another thing to remember is that for degrees of freedom, you want to use the smaller value between n1 minus 1 and n2 minus 2. When sampling without replacement, you should check that both n1 and n2 are less than 10% of the population. If either population distribution has an unknown shape and the corresponding sample size is less than 30, use a graph of the sample data to assess the normality of the population distribution. Don't use two sample t procedures if the graph shows strong skewness or outliers. You can use the two sample t interval command line to construct a confidence interval for the difference between two means. Press stat, then choose tests and go down to two samp t int. Choose stats as your input method and enter the summary statistics for your first sample and your second sample. Then enter your confidence level and choose no for pooled because you're calculating a two-sample t interval. And then select calculate to calculate your interval.
Here are some problems from previous AP exams that cover confidence levels. Thank you for watching, and I hope you found this helpful.